We've been gazing at Jupiter, and we told ourselves that we had understood. A massive gas giant, a huge ball of storms and hydrogen, an early Solaria remnant system. However, what if that narrative was never the complete picture? What if Jupiter weren't simply a world of chaotic weather systems and volcanic moons, but something far more calculated and perhaps even aware? After circling this colossal planet for nearly a decade, NASA's Juno spacecraft is getting closer to its end. But prior to its plunge into the whirling abyss, Juno has returned a message no one anticipated finding: data and images that defy the very rules of planetary science. It captured more than just beauty, but a collection of motifs, pulses, and reactions that may indicate Jupiter is not as described, and it may never have been just a planet at all. That the final chapters of Juno began with a descent into Io's chaos, a moon that appears so alive and volatile. Juno's close flybys in 2023 and 2024 came within just 1,500 kilometers of the surface, where it captured images of dozens of erupting lava fountains spewing kilograms into the empty space. But what caused these images to be so unsettling? Not only the violence, but the order within. A few eruptions were recorded to have occurred nearly simultaneously, pulsing almost as if responding to an internal clock. More bizarre still, Juno's instruments detected a fluctuation as it moved across the massive lava lake called Doloki Patera. This wasn't a minor deviation. It was a deliberate oscillation, as if something in Io's subsurface had responded to the spacecraft's presence. The data suggested that thermal activity was coordinated across volcanoes separated by hundreds of kilometers, which ought not to be possible under any known models of tidal heating. Could Io be responding not just to the stress of gravity, but to something more? Juno's mission was never just about the moons. It was about peeling back Jupiter's thick, vibrant mask. As it dove into the planet's north polar region, its microwave radiometer uncovered an alarming contradiction. While images in the visible and infrared revealed a well-formed, stable cyclone at the pole, the microwave data revealed nothing. The storm's eye was devoid of a deep radiation signature. It appeared as though the storm's structure was only present on the surface, without any real subsurface depth. Other cyclones in the area displayed intense energy in the subsurface, but not this one. It was empty, silent, and inaudible to the instruments that peer beneath the clouds. One scientist unofficially called it the mask, a perfectly fabricated weather event, circular, with absolute tranquility in the middle, free of the disorder that defined every other Jovian storm. The implication? Something or someone may have shaped that vortex for a purpose, while passing through Jupiter's chaotic radiation belts. Juno's instruments unexpectedly captured anomalous thermal activity coming from one of the tiniest moons in Jupiter's system, Amalthea. At 84 kilometers wide and shaped like a potato, Amalthea was never expected to be of any major interest. However, during Juno's 59th perijove, the probe recorded something strange. Amalthea was emitting infrared light. And not only that, it pulsed rhythmically, synchronized with Juno's flyby window. The beats diminished when the probe moved away from direct alignment. At first, this was attributed to induced electric currents or tidal friction from Jupiter's magnetic field. But the emissions became more alarming when analysts discovered an ideal alignment between the pulses and a previously ominous magnetic wave emanating from Jupiter's equator. It seemed as if Amalthea had been signaled and then responded. It a coincidence, or had the small moon been a node in a larger planetary system of communication? Even though Saturn's rings are well known, Jupiter has a system of faint, dusty rings of its own. However, during Juno's recent close passes, something shifted. The spacecraft's sensors recorded readings of an abnormal density in the outer edges of these rings, places where material moved contrary to models of gravity. Instead of rotating smoothly, small clusters of particles accelerated in opposition to their orbital path. briefly shifting out of alignment before returning to equilibrium. These distortions were subtle but recurring. Surprisingly, they always occurred when Juno crossed through a specific magnetic corridor emanating from Jupiter's atmosphere. No natural explanation exists for this. Jupiter's rings are too thin to encourage this kind of vigorous reaction. One theory suggests charged plasma particles affect dust behavior, but the patterns were too precise. According to one physicist, they move as though someone is telling them when to move. If this is true, Jupiter's rings aren't just dust. They are a tool. One we've only just started to hear. The Great Red Spot has mesmerized astronomers for centuries, a colossal storm twice the size of Earth, spinning violently for more than 350 years. Juno's high-resolution infrared and microwave results from its 59th and 62nd perigeos revealed something previously hidden. The spot is becoming impossible to predict. Deep temperature gradients inside fluctuate irregularly, while surface winds continue to appear stable. In just one pass, Juno found an abrupt thermal pulsar 20% temperature increase in the storm's core within less than 1 minute. Even more troubling, the red spot is not a closed system. Juno's sensors caught a filament of hot gas emerging from the spot and traveling east before fading like a tendril into the surrounding cloud bands. Weather doesn't behave this way. It doesn't broadcast streams. Unless the storm is more than just that. Some researchers now speculate that the Great Red Spot might be tapping internal energy sources possibly deep within Jupiter's core. Others, more cautiously, describe it as a planetary pressure valve. However, one thing is becoming apparent. The storm is not fading away. It is settling down. It may be a component of a system too extensive and ancient for us to understand. Jupiter's striped cloud bands are driven by powerful jet streams. Bands of atmosphere that whip around the planet at over 300 miles per hour. But during Juno's 61st to 66th orbits, its instruments began to detect strange behavior in the jet stream regions. In the northern hemisphere's folded filamentary region, the jet streams began to disintegrate into chaotic recurring patterns. Yes, they were beautiful, but structure was concealed within that chaos. When analyzed, the cloud movements in sequential image data showed mirrored geometries, hexagons, and spiral curves, like fractals tracing weather systems. Using motion mapping algorithms, NASA analysts found motion loops that ran every 6.2 hours. The duration of Jupiter's rotation, but half of the loops completed in 3.1 hours, and some even halved again, forming regular quadrants that looked like gears in an apparatus. The data didn't just imply movement, it suggested a planetary rhythm, a mechanical heartbeat. Was it atmospheric turbulence in a thick atmosphere, or something entirely computational? Juno was seeing storms, yes, but storms that were aware of their own timing. One of Juno's final objectives was to identify Jupiter's internal structure, especially its water content. Using microwave radiometry, it mapped the dispersion of oxygen and hydrogen throughout the planet's upper and middle atmosphere. However, something was off. While water was expected near the equator, Juno discovered unexpectedly low concentrations in the heart, where heavy ice-derived elements ought to have been abundant. Instead, they were sparse. This led scientists to consider a frightening possibility. Jupiter's water is being moved. But where? In a 2024 data dump, Juno noted massive thermal readings in the lower atmosphere, just below the equator, too extensive to be explained by solar heating and too diffuse for volcanic activity. The signature resembled a warm liquid, a fluid ocean beneath a dense gaseous shell. Such a structure defies current planetary formation simulations. But more alarming was the movement, columns of material moving up and down like respiration or convection. Is something moving within Jupiter's depths, releasing air outward during storms? Juno's mission is scheduled to end in September 2025. As the probe makes its 77th and final dive before disintegrating in Jupiter's upper atmosphere. However, in its most recent orbits, something odd happened. On Juno's 69th perigove, its communication systems went dark for 3 seconds, not due to solar interference or hardware failure, but a total data halt. When the signal returned, no fault was found. However, the duration was precisely 3.141 seconds, a number eerily close to pi. It could be a celestial coincidence, but during that window of silence, the probe was over a zone in Jupiter's atmosphere, where magnetic resonance had previously spiked a point of convergence. NASA called it a minor telemetry delay. Internally, engineers lacked certainty. One document included a handwritten note. The world blinked. Since then, mission procedures have changed. Every subsequent flyby is being diverted away from that coordinate. Is Juno being safeguarded, or is it being kept out of sight? Juno was never intended to endure this long or to reveal enigmas that challenge the fundamentals of planetology. It was built to observe, measure, and send data. However, Jupiter had other ideas. What Juno uncovered wasn't just weather, magnetism, or volcanic fury. It found patterns, rhythms, and echoes of coordination, whispers of planning from a planet that pulses in sync with storms that vanish under microwave vision. From rings that move when nothing should, to clouds that spiral symmetrically. Jupiter was no longer a planet. It began acting like a system, with layers we had just begun to notice and safeguards we were never meant to bypass. Now, as Juno's final dive approaches, it will be destroyed within Jupiter's upper atmosphere, not because it's too old or lacks fuel, but perhaps because it saw too much. Maybe we weren't orbiting a gas giant? Perhaps we were orbiting a gate, a processor, a signal tower, or something far older and deliberate. If so, Jupiter isn't just the largest planet in our solar system. It might be its most carefully concealed secret. If this rattled your perception of the world, make sure to subscribe for more information that people won't dare touch. Also, tell us, do you believe Jupiter is merely a natural planet, or is there something at its core that we were never meant to understand? Let us know in the comments.